everyone. So today we are going to do one easy level Leet code problem called isomorphic strings. So, so it is very simple. I mean the question. So you are given two strings. So you have to replace each and every string with the other string. So if every string of S can be replaced to get T. So we have egg and add, right? So you need to replace every string of S in order to get T. So this is the thing. So I'll explain the other conditions later. So this is egg. Okay, and then the other one is add. So you're given these two strings as the uh, input. So if you replace E with A, and if you replace G with D, you can convert EGG to A D D. So you got it. So the answer for this is true. Right now, let's check out the second example. Foo bar. So create F, can you replace it with B. Next O, you replace with A. Now here's the condition. So all occurrences of a character must be replaced with another character while preserving the order of characters. So the order should be preserved. And the second condition is no two characters may map to the same character, but a character may map to itself. So this one is easy. So E can map to E, so that is fine. But no two characters may map to the same character. So what does that mean? So coming back here, no two characters may map to the same character. So now O, in order to now coming, so F you got B, next O you replace with A, right? Now again you have to replace O with R to get bar, right? So is this allowed? So basically what you have done, so the same thing you're trying to replace. So basically you got F you replace with B, O you replace with A, and next, so no two characters may map to the same character, but a character can map to itself. So this is one more case where O and R cannot be mapped to. So this is not possible because C cannot be made identical, needs to be to both A and R. So O should be mapped to both A and R. So this cannot be made identical. So hope you get the point now. So and one more condition is I need to teach. Now you come here. O and A you place it there, that's fine. So next, now A, O, yeah, so O you have already replaced with A. Now you can't say now you're replacing O with R also, so that's not possible, right? O you have already replaced with A. Now again, O you can't again put R over here. So that is one example. So now let me take one more example. Egg can add to if paper title. So see, there is one more condition. No two characters may map to the same character. For example, F is mapping to B. Next, A also cannot map to B. So you can't have something like FB and A should also, you can't have something like this. So this is incorrect. So that's what this condition is saying. Okay, so now how do you do this? So basically you need to know where, so you need to know where which letter is mapping to which one. So for that one, you can basically you need to know this mapping, which it has mapped to each other. So for that, you basically use a hash map, right? So I wanted to explain one more edge case.
HTTP request, everyone gets that. Yeah, I send some request and I get some response. You must have heard of HTTP, right? Yes, no, yep. HTTP is what? It is actually application layer protocol. Okay, I'm giving you an example. Everyone just listen to it. So what happens over here is, you see, I have application layer protocol.
So
okay, this is application layer. Okay. Now, before I actually go into the details, let me show you how a basic HTTP request looks like. Can we do that? Because I'm sure a lot of you are completely new to this. So I'm sure some of you might not have seen it. So let me just quickly show it to you.
let's go to this TUF. This is one more good edge case. You can now see this apple, double B and BM, double B and BM. So now to get this one, you map A to B. Next, you map P to, you need to map P also to B to get the correct lettering, right? But this is not allowed. So that's what they're saying over here. No two characters may map to the same character. So no two characters may map to the same character. That's what they're saying here. So basically, what can we do here? We are using a hash map. So one more thing to note here is, if this letter is isomorphic to this one, then this word is also isomorphic to this one. So basically what we'll be doing here is, so let's take one more example, paper. Okay, and let's do this one. Egg, add. So here you map E to A, and next over here you map A to E, and next over here you map G to D, and next over here you map D to G. So basically what you're doing, each time you add a map, and then each time you check, okay, is G already there in this hash map? No, then I can do. Is D already present in this hash map? No, then I can do. So let's do this again. So E, okay, now map is empty, map E to G. Next you come here, map is empty, you map A to E. Next you come here, G. Is G there in this key? Is G present as a key in this map? No. So you add G to D. So follow my wording. So next, is D present? Is D present here in this map? No. So you put D mapping to G. So that's it. So now let's take this example, foo and bar. So same thing, what we do, the now map is empty. This is one map, this is another map. Now map is empty. F you map to B. Okay, now this map is empty. B maps to F. Now O is mapping to now okay, now B is mapping to F. Now we come back to this map. Now you have O. Is there an O present in this hash map? No, there's no O present. So you can put O is mapping to A. Next you come to this hash map. Is there A present in this hash map? No. So you put A and make it point to O. Next you come to this hash map. Is there O present in this hash map? Yes, O is present. But what is O is pointing to in this case? O is pointing to R. O is pointing to R. So like I said, two characters, no two characters may map to the same character. So no two characters may map. Okay, sorry, not that one. So now O is pointing to R, but it's not possible, right? Because O is already pointing to A. Now let me do this again. Okay, now A is pointing to O. Okay, A can point to O. Now when we come to O, now this map already contains O, but it, what it should ideally point to, it should point to A, but here it is pointing to R. So here only it is false. So you can't, ideally it should map to A, but it's mapping to R. So that's not correct. So you make it false. That's it, you return false. So I hope you understood the steps now. Each and every time you add a map, you check if that map exists. I mean, you add a key value pair, you check if the key exists. If the key exists, then you need to check to what that thing is mapping to. For example, here O is already existing. O is already here, right? O was already here. Now, when you again got an O, you should check, okay, O should ideally map to A, but here O is mapping to R, so it should return false. So that's the logic. So this is the logic. So now let's implement this logic. Okay. So first we create two maps. So it should have a character, comma, character, s map is equal to new s map. Map of character, comma, character, s map, sorry, t map is equal to new hash map. Next. So basically I have created these two maps over here. So now, so also the thing is length will always be equal, so you don't need to worry. So now I will iterate through each of the things for int I is equal to 0, I less than s dot anything you can take, then I plus plus. So next when you come here, I will put s character s char is equal to s dot char of I. Next, char t char is equal to t dot char at of I. Next, so now if map dot contains key s char and so for example, if it contains key so is containing here and map dot get of s char is not equal to this guy over here. So if O is pointing to A, but need to check if O is pointing to A over here as well. So you need to check map dot get, you got get, you'll get this. Next, you need to check it with tchar. That is, you're checking this one with this one. So tchar, tchar, T. So this is one condition, right? And you need to do vice versa also. Or map dot contains key tchar and map dot get of tchar is not equal to scar, not equal to scar, right? You return false, and then if that's not the case, just do map dot put of scar smap dot put of scar comma t char. Tmap dot put of tchar comma scar. So now that's it. If everything is put properly, if this condition is never entered, you can just return false. Let's see if this works. Run statement. Yes, map that contains S map, D map, it is true, output is false. If S map contains the key SCHAR and S map.get SCHAR, it should point this S map. Hey, hey, am I returning false here? It should return true. Yes, that's it, guys. So and then so the time complexity of this one will be O of n, because we are just iterating through each of them once. So each of the we are not even iterating through each of them. We are just iterating through one. So the longest can be n. So time complexity is O of n. Space complexity is O of 2n, where n is the number of characters we store in the map. So 2n, it again comes down to n. So it's O of n, space, time and space complexity is n, O of n. So yeah.